In the previous session, we have drawn and estimated our first CFA model. You have mastered the Amos graphical interface and can now create models. In this session, we will look in more detail at the estimation of models and its outcomes. Specifically, we will consider model fit. By the end of the session, you will be able to tell whether your model is good, bad, or indifferent. Let us begin with a more in-depth look at our model estimation. We are starting with our three-construct model, which we saved in the last tutorial, at the point where we clicked Calculate Estimates. Recall that when we try to estimate the model, we simply press the icon Calculate Estimates. When you do that, the software defaults to its basic settings. To examine whether a model is good for purpose or whether data is fitting your expectations, it's a good practice to ask the software to carry out additional checks. This is done by clicking this icon, Analysis Properties. Go back to your model and click first on the grey arrow here and then on this icon, Analysis Properties. Amos will take you to a menu with several click-through tabs. The tab we are interested in is this one called Output. Most of these options here are for nerds, and normal people like you and I are likely to only use this Output tab. And in that tab, you should click Minimization History, Standardized Estimates, and Squared Multiple Correlations. Once you've done that, close the window. And now let's run the analysis again. We will click Calculate Estimates. You will see that from the graphical side of things, nothing has changed. But we have much more stuff now to analyze when we look at the output of analysis. To see the details, please click this button called View Text. Once you click it, the software takes you to a new file called Amos Output. What does it all mean? The abbreviations and numbers within this file tell you how good your model is and how well it explains your data. What we are interested in this tutorial are the indicators concerning model fit, which can be found just here. Click on that and you will see a new file called Model Fit Summary. Let me start by saying that there are no hard and fast rules which indicators to choose and what indeed is their optimal level. There isn't one test that best describes the strength of the model. We typically use a variety of indicators, and some common ones of those include chi-square, RMCEA, NFI, and CFI. I will go through them one by one. So let's start from a chi-square. Chi-square is captured in this first box here under the abbreviation CMIN. Chi-square compares the theory to reality by assessing similarity between the estimated covariance matrix, your theory, and reality, the observed covariance matrix. The larger chi-square, which can be found here, the better. However, because chi-square is affected by model complexity, inflated with model size and sample size, it alone is insufficient. The next index that we look at is this one here. The number in the corner corrects chi-square, taking into account the complexity of the model. Ideally, you would like to see a value below 2, but values between 2 and 5 are considered acceptable. The next most popular fit index is root mean square error of approximation. It can be found by scrolling down the file. It's just here, RMSEA. The values of RMSEA can be found here, and they should be below 0.05, but values between 0.05 and 0.08 are acceptable. Next, we will look at some incremental fit indexes that can be found further up the file. For example, normed fit index found here, or comparative fit index found here. With those, you are hoping for values that are above zero point 0.9 for NFI and 0.95 for CFI. Finally, a third group of indexes are parsimony fit indexes, which are similar to the notion of adjusted R-square, and they correct for the complexity of the model. GFI is one of those indexes. Goodness of fit index it refers to, or adjusted goodness of fit index found here, should have values above 0.9. So how good is our model? From the look of those indexes, high chi-square, low CMIN, good fit indexes throughout above zero point 0.9, and low RMSCA all mean that our model has a very acceptable fit. Let me recap. In this session, we have evaluated the fit of our model using a range of indices. You will now be able to tell from looking at any model whether it is good, bad, or indifferent. In the next session, we will consider the quality of our measures. More specifically, we will check how well our observed variables measure the latent constructs. See you then. Bye.